Hey everyone, welcome to GraphQL FM. Really glad to be here again today. Sorry for last Tuesday, we had to reschedule, had some issues at work, but we're here now. I'm with Tony as usual. How are you doing, Tony?
Hey, doing well in San Francisco. Just trying to, breathe air and not be on fire. But other than that, doing well.
Yeah, we were just talking. It doesn't look too orange behind you, but that's the magic of technology. Everything's still on
Yes, the
fire,
magic of TV.
unfortunately.
You're cheating, Tony. You're masking over global warming's, signs here.
Yeah.
But it's okay. I appreciate
Next
your
one, I'll
camera
make sure
trickery.
add some flames in coming, from the sides and just have
Yeah.
that smile like this is fine, dog.
Yeah, we need.
Definitely.
Yeah, that's right. Yeah.
So we're joined by Jesse Rosenberger today from Apollo. Jesse, welcome to the show.
Oh, thank you for having me. First time guest, long time listener. Yeah, it's you guys you're an FM show, right?
At least the name.
You know what?
Yeah.
What is your frequency? Have you come up with what your frequency is yet?
That's a good question. Is there a GraphQL number or something?
I was gonna ask, GraphQL is transport agnostic, so I don't want to just reach for HTTP status codes, but and 207 would be the one I would reach for. And I think, I think we've talked about this in the past, actually, 207 being such a great status code for GraphQL.
True.
But what is within it stops at 125 or something like that?
Good question.
What if it was what are the lower HTTP status codes, in the 100s?
Like continue
It could be
or something?
101.
101.
It's 101, switching protocols.
I like to think the discussions we have are a little bit higher than 101 in terms of GraphQL. It's not really
you're
what is
right.
GraphQL, but
It's
get into the nitty gritty.
I guess 200.
102,
okay. It's just okay.
Okay. It's okay.
It's okay if you're a little bit off the higher end of the frequency range. It's okay, I think.
Or maybe we can do
Great to be here. Thanks for having me.
It's so great to have you. We've been wanting to talk about Federation for a while, and I think you're definitely one of the experts out there. So that's awesome. We're going to talk about Apollo Federation today. But before we jump into too deep, I kind of wanted us to start with a bit of context and kind of talk about GraphQL history around dividing your schema between services, because we talk about that often. Facebook's use case of GraphQL is very different from some others you've been seeing. It started as that one giant monolithic graph, and we've been seeing more and more companies, probably even more than that monolithic context, companies joining multiple services as one GraphQL server. So what's the context here? I think Apollo were one of the first ones to kind of tackle that problem. There's schema stitching. Can you give us a bit of context on how you got to Federation?
Yeah, schema stitching I think was a really validating experience, and for anyone who hasn't used schema stitching before, it was roughly, to put it simply, using code to define sort of the relationships between different graphs, and it was using code in the language that you were using. So often, our schema stitching stuff was written in JavaScript. That was where you reached for first. That was a really validating experience in that I think it just proved that people wanted to connect disconnected graphs. They really wanted to bring them together. Data was not always exactly where you needed it to be, for all sorts of reasons. And I think that was watching everyone kind of dig into it was definitely it was just proof that people needed to expand graphs in very specific ways.
Yeah, and then I guess
oh, sorry.
At some point schema stitching was all the rage, and then something happened. I don't know when, but the usage of, or at least people recommending schema stitching was kind of more rare. And what happened there? What did you kind of notice?
I think it didn't happen overnight, but the adoption of schema stitching grew and grew and grew, and we found that it was, and we found that it worked really great when you were getting started and you were joining a few fields here and there, but that it did tend to get a little bit unruly at a certain point once you were trying to, like, as a human, actually trying to draw the connections between, like, where does this connect precisely? I think that for me, I would go into like GraphQL conferences and people would be asking about schema stitching, and on more than one occasion, people literally brought me like laptops with schema stitching code, and were like, "So it's not working, and I'm trying to figure out what it is." And like first of all, it certainly could have been documentation flaws and things like that. I want to say that we tried to cover all of those bases, but like, who knows? Maybe we could have done better education about how to use it right. But it was after like the third or fourth time that happened, where I was kind of like, I don't know if this is right, because I cannot on the spot figure out how to, like, which like schema name you disconnected from the other one, or if you're referencing the schema you're delegating to, or the schema that you're, I don't know. I was just like, yeah, but I would usually find it, but it was just like, I don't know why I would expect anyone else to just catch on to this right away. Or sometimes there's like extra attributes you needed to add to do it in a particular way.
Right.
And conceptualizing around like where something has been remapped is, it's difficult for engineers, but I think it also becomes difficult as that pattern propagates out to other parts of the company. So like if you were trying to have a product manager reason about the way that your data is connected in the graph, and maybe they're just not up to date on schema stitching, which wouldn't be entirely unexpected, that sort of ergonomic to them became a little bit tricky, and I think the complexities of it were a little bit hard. It was a little bit difficult to statically validate, I think. It was just a big part of it. I also don't know if the portability of writing it in one language was working out to everyone's benefit. And I can talk about that if we page into the Federation details here, how I think some of those things are better in that environment. But that's kind of how I think we get. And we started exploring. Like, we knew schema stitching was doing great things, and we were like, all right, well, how do we make this turn down the configuration way down, because that's sort of where those things. I'm usually on the side of more zero config-ish things. Like I certainly want escape hatches and stuff like that, but I like when people take opinionated sort of stances on a way that will hopefully cause me the least amount of pain possible as a developer, so I can get on with building like really cool apps and stuff. I don't really want to solve some of those same struggles again, and I don't want to like lump that into like the history of like computer engineering struggles that we've like surmounted time and time again. Like I do think we're doing better incrementally, but anyways, I guess that's the high level.
That makes sense. Yeah. Would it be right to say most of these complexities or issues were coming from kind of like that the dependency side of things, like conflicts, things not being as expected when you're trying to stitch? And was that side like the most complex one?
I mean, a lot of the times, like completely disconnected code bases are being joined together here, right? So without like a single source of truth of like what exactly the expectations, the contract of the schema, like there's a reason GraphQL has a schema, right? It's because we have a contract and we want that contract upheld. And if the contract is gone, well, all bets are off. So I think the complexities of that are 100% involved. Have either of you used schema stitching before? I'm curious what your own perspectives are. I don't want to just say what my experience has been with it, but
I haven't personally used schema stitching, and I don't know. It seems like it could be appealing at times, or it seems like I could have seen the appeal. I was a little bit skeptical and kind of stayed away from that model.
Yeah.
I don't know. How about you, Marc?
Not in production for anything real. I've tried it on my own for fun, but it reminds me. So I wrote this blog post kind of against schema stitching 2 years ago, where I think my main worry was like people wanted to decentralize their schemas and define them in different places. And they ended up what I felt like would probably be like something very centralized where you connect things and like that brittle kind of like gateway in the middle. And in that blog post, I lazily said like somebody should invent something where you can just in a service like link like to another service or something. And little did I know, obviously the Apollo folks are already actually doing that. So that's why like Federation is very. I think Federation aims to solve a lot of that, right, Jesse? Like not having that central brittle point of connection, and instead like having that orchestration or like communication between services.
Yeah, I think Federation really tries to make it so. Well, by the way, thank you for your wonderful blog posts. You do write a lot of great blogs, and also your book is incredible. I finally bought it during GraphQL Summit this year.
Nice.
Just want to say, like, and I had heard plenty about it before. In fact, I had literally been on calls with people who have read out like paragraphs of it, and I'm like, yeah, that sounds pretty good. Like, I like that. And like, I think I was in the maybe in the API best practices topic room at GraphQL Summit. And I started like making a recommendation to it, and I was like, "Wait, I haven't actually bought this book yet," which is kind of silly because I know what's in it. I kind of know the stories that it suggests, and I was like, "All right, that's it. It's happening right now."
Well, thank you so much. Thanks for the kind words.
Yeah, absolutely. One of the things that I think Federation aims to do a lot better is really have a great tooling story. And this is something that we are continuing to invest in a whole bunch. The idea that you can collaborate across graphs with graphs are going to change on different sides, of course. Like those are going to be those contracts are going to have clauses in them that allow the engineers to escape from their past design decisions, and that's okay. But the tooling's responsibility should be making us aware of exactly like how that's evolving, so we can get an alert that says, hey, like the thing you're doing will actually break the other 3/4 of your team, your company, or whatever, who are relying on this, because you put data out there and people start using it. It's really interesting. People start depending on it, and if you don't know exactly how they're using it, or like if you're remapping a field and they are looking at their metrics and they're like, no one's using it, and you remap it in your schema stitching and it doesn't map to the same name anymore, and I don't know exactly what happens, but tooling can help. It's a big I think it's a big part of the Federation story, and we continue to try to come up with new ways to make that work even better and faster, and get a really nice pulse on exactly what's happening across disconnected graphs.
Yeah. Before we get too deep into it, Jesse, could you give us I guess like the high level difference between stitching and Federation?
Yeah. So it's if anyone's used SDL before, schema definition language, you're familiar with it. It's a really nice human representation of a schema. It's something that a team could share with a lot of people in their organization, and they can reason about it pretty effortlessly. We leverage directives to basically annotate the graph with what the relationships are, how to. We have this concept of entities, which are basically unique representations of a thing. So a book, for example, and fetching a book isn't always by ID. It's usually by all sorts of other identifiers that mean things to authors. ISBN numbers, I think, are things. And you might need to declare exactly what those are. And because it's declarative, and because we have tooling that sort of double checks to make sure the thing that's here and is in the other graph, and that you have those relationships defined, it's not in code. Also, because it's not in code, and if you are using something that's capable of consuming SDL, it can move between languages as well. Like the same, like you can have something interpreted and in one language or the other language. And Federation at this point has been like the Federation specification that we published. It has been adopted in so many languages now. Like Go, PHP, Scala, Ruby, Rust, Java, Kotlin, TypeScript, of course.
Yeah.
Who am I missing? Python. It's something where you could, you know what, if you decide to change your mind later on and you want to rewrite your resolvers in another language, just you can take your schema on the road and rewrite it, and the contract is still the contract.
Yeah.
It can evolve, I guess, but it's declarative. Like using directive, that's the high bit. It's very directive. It's statically analyzable, and that is pretty cool.
Yeah.
You can generate types from it really easily. You know, of composed graphs. CodeGen is a big part of that story as well.
The awesome thing
Nice.
is the fact that it's a specification. It's not a federation library that you need to like write in every language. Well, you might do it, but you're not forced to, right? As long as if I have like a legacy Go set up in GraphQL and I don't want to bring a federation dependency, as long as I expose an SDL with that specification with these kind of like entities and links, it's just going to work. So it's pretty nice. Like you don't have to do like a lock upgrade to all your services to have like the same package version. As long as they respect that specification, everything should go well. So that's pretty cool.
And the specification isn't all that long, I promise. Like it's not like RFC 5, like we're like, oh, this one has like a different connection to it. It's actually pretty concise. So it's the concept, I think, is simple. But.
Yeah, the concept is simple, but what's going on inside can't be that simple, right? So that's kind of like what I want to dive into a bit as well, because
Nice transition.
nice.
What do we hide behind this?
Right, pretty much.
That's a fair question.
So I guess the main complexity hides into the orchestration, like the query plan, I bet, because so as you said, the SDL is declarative. It tells you kind of like how things are linked, how things are extended. When I make a request or make a GraphQL query to, let's say, that spans 4 different services, something needs to decide what the most efficient way of fetching that data is. And that's the GraphQL gateway, I assume, and that's written in Node, right?
Yes, it is currently written in Node. However, we are on a journey to write it in Rust.
Nice.
And we have just finished the very first part of that, actually. And if we've done this correctly, nobody will notice. Because one of the first steps we're doing here is that we rewrote the query planner itself, the thing that builds the query plan, not the part that executes it, but the part that is computationally expensive to figure out exactly what is optimal. Wrote it in Rust. We're compiling it using Wasm pack, an incredible tool by Ashley Williams, to a Wasm module, and we are loading that in to the existing gateway, and it's pretty cool. We've seen like there's like this idea of trampolining across like the boundary between like JavaScript and like the Wasm runtime, and we were playing around with it quite a bit, but we're pretty impressed by especially as some of these operations that are coming in are pretty complex. Like they get very tall, very wide, span a lot of services, and computationally they can be expensive. Now, if you have like most enterprises have a finite number of like unique operation shapes, even though GraphQL does let you kind of do whatever. And it depends a lot if you have a public API or not. But for a lot of organizations, you know exactly what your list of operations is. So we can cache query plans very, very well. So anything that's baked into a bundle, for example, like we're not. Yes, it does take 0.75 milliseconds or something to calculate it in some cases, but also on like the really crazy operations, it was taking like 300 milliseconds. Still cacheable, but we do know that the complexity in the query planner is, well, we're going to turn it up because we feel like it needs to be turned up. Like we need to do more things, right? We think our initial approach at it is is great. It tries to optimize the number of calls to each service. There are dependencies where sometimes it needs to like reach into one to get an entity to fulfill the response it needs to get from the other one, service B or C or whatever. So there can be some back and forth there, but we think by writing this in a language like Rust, not only allows us to just, we think, move at a really nice pace in terms of how we can understand and reason about how the query planner is able to work, because it's a great static language, and just kind of bring on more and more concerns to the query planner and let it think about endless number of things. We haven't even fully figured out all the things we want to do yet, but we do know that we're seeing huge improvements with the query planner in its new state. So that's pretty great. So it'll be going at the actual gateway. We'll be getting that treatment pretty soon. We ran it in our own environment over the last weekend actually, and 4-day weekend. Pushed the production on a Thursday. To be fair, we ran it in our own staging, and we were really confident in what it was able to do, and we had a really nice period of taking all of our own query plans and just running them through new and old and being like, did it work? Did it plan the same things? Did it do what it was supposed to? And it did, which is really great. So we're really excited to get that out. So yes. There's a query planner and there's a gateway.
That's so awesome about Rust, because we had Uri Goldstein last week, and he's working on GraphQL Mesh, which does some similar things and other different things. But he was mentioning you can run it client side as well, kind of like the gateway. And if you're doing Wasm, could that mean you could run a federation gateway on the client side if you needed to?
I mean, you can use Wasm pack, and we pass -- target Node.js, but you can definitely pass -- target the browser, and it will run.
Yeah.
So once you get the gateway in the Rust implementation, is that also a Wasm thing? Is that just Wasm your platform?
Yeah. So we believe that we will continue to build the rest of the gateway in Rust. Mm-hmm. That obviously comes with some question marks about user code, which we want to try to keep as much user code out of the gateway as possible, largely because it becomes this thing that is owned and has to be reasoned about by multiple teams, and it's much more difficult to analyze statically. So if we can sort out all of those things, we think that first of all, a Rust binary is something that can be as a piece of infrastructure can just be run, right? It's a little bit less the node runtime. You need to have that, and also is it is it one thread still? It's just one, yeah. But we can do some fun things, right? We will keep exploring the fun things that we can do within the confines of the current gateway. We're thinking we could use worker threads, which are stable in Node 12 now, and just run a bunch of worker threads with a bunch of query planners. But again, the query planning is a fun story, and we're looking forward to where it goes. But we're doing a lot of work on Rust now, and we're pretty excited about the language. We're redoing our CLI also in Rust.
Nice.
I saw you hired Ashley Williams, as you were just saying, and now it makes so much more sense. What a great hire. That's unbelievable.
Yeah, no, she's absolutely wonderful, and I'm pretty excited about everything that she's already done and everything that she's doing for us.
That's
already,
amazing.
So.
So I have so many questions. Something interesting I was thinking, Tony, is you have a kind of more service-oriented architecture compared to what we do at GitHub. I was kind of wondering if we could take your example and see how federation could work, because your individual services don't currently expose GraphQL schemas, right?
They do not. They have a protobuf definition. So
Jesse, how would you approach, let's say a client came to Apollo and you wanted to kind of propose an architecture with federation, would you kind of every service that is existing, you would start exposing a GraphQL schema with the federation spec, or do people like kind of spin up new services that act as those GraphQL services in front of everything? What do you see like most often?
Yeah, I mean, it could certainly go each way. I do wonder, for example, if you could just generate the services SDL from, I don't know if this would make sense, generate it from the protobuf and have that be like the thing that's registered with the gateway, and then the gateway would still send GraphQL queries to the downstream. Would that work?
Yeah.
Or would it have to be, I mean, you can still define data sources, like custom data sources at the gateway to communicate in whatever protocol that the gateway needs to communicate to the underlying services with. It doesn't have to be GraphQL, although we've found some interesting like GraphQL wins even just doing that. Like automated persistent queries, by the way, actually works really well when you're talking from the gateway to the downstream clients. But yeah, I'm curious if you can imagine that working for you.
Yeah, I can. I think the trade-offs are interesting when you talk about like putting GraphQL everywhere versus like if you've already got some other SDL type thing in place. So it's also interesting like tying that one-to-one, because when we talk about our GraphQL API, we build it specifically for our client, like user experiences that our clients are building, and that's not always exactly the service protobuf, you know.
Yeah.
So I think yeah, I'm not sure. I'm not sure how it could work. Like you could do it. I don't. The part where I'm unclear is like where you would want to do it in a system that already exists this way.
Yeah, I mean, there is, I guess, the option of putting another layer in front of things like that. If the services already speak protobuf, then especially with like JavaScript being as dynamic as it is, generating like dynamic protobuf per request is also sort of like a weird thing to do. And in fact, in most of my tests, once I like run the like JSON is the subset of JavaScript, right? So if you're running in JavaScript, like it's pretty fast. Like the V8 is not messing around when it comes to serializing JSON.
Yes.
Now I can't say the same for the thing consuming it on the other side if it's not like Node as well. Like it seems pretty like, oh, that's not nearly as good as JavaScript, is it? JSON compresses surprisingly well. Like really, really well actually. And like the gzip stuff, like, or I don't think it's gzip anymore, but whatever compression you're using usually happens in C++, so that's pretty quick. But yeah, sometimes maybe there's an in between. I don't know. It's an interesting place. If you have some legacy stuff that you need to convert, that is. I don't know what I would recommend in that case, to be honest. But I do know that tooling is probably going to be our friend, and make like at least. I mean, both of those things can be statically analyzed, which is pretty great.
Right. Yeah, that's a good point. The tooling for GraphQL, in my experience, has been quite a bit richer than the tooling for protobuf. And I don't know if it's just like the use cases are I don't know, different. Like you don't normally expose protobuf for like many people to use that you don't know, or across the internet. But yeah, that's an interesting point.
We use protobuf for our own like the admission. We use protobuf for sending like tracing metrics to our ingress servers. If you've turned on Apollo Studio, and that's what we use behind the scenes. But the story sort of is relatable to me. The tooling, I don't fully. I know we're using the JavaScript implementation of protobuf, which, again, like you're making like turning JSON into binary. JavaScript's not really a huge fan of that.
Yeah.
The tooling for GraphQL is like surprisingly really good for how young it is if you compare to other things. Like I've been working with OpenAPI recently, and like finding anything that works with an OpenETI schema is like really hard, either because there's like inconsistencies or like you've got the wrong version. Yeah, we're pretty like spoiled on the GraphQL side. I feel like the tooling is great. There's like you'll always find something, and I mean the specification is quite well. It's not simple, but it's simpler than some others with GraphQL, and it seems like tooling just always works. Maybe that's my experience, but it's nice.
I have noticed that.
Yeah, I think it's pretty good. Sorry, go ahead, Tony.
I have noticed that same kind of like specification ethos in the parts of Apollo that I've used, like the you mentioned the automatic persistent queries. That's also a very like pretty simple specification, but very powerful with what you can do with it. And
yeah, and I was pretty impressed by like we were trying to think like we don't have to make such like these operations, because like one of the things we do in the gateway when we have to send requests to downstream services, we do have to like ask for like underscore type name, because like we don't always know exactly what the concrete type is going to end up being on a union type or something like that. So we do need to get that information back to understand it. And we were like, oh, a lot of these same operations, how on earth could we reduce the amount of like bytes on the wire? Like, this story has been answered. We have a pretty simple implementation here. It's like take a SHA-256 of the operation and send that over. It works a lot like basically e-tags, right? Like a pretty simple hash the document. Oh, I already have that. Don't worry about it.
Yeah. It's nice how like it shakes out from like you have like your specification is your foundation, and then you get all this tooling on top of like that shakes out from those decisions. It's pretty nice. Nice to work with.
Again, on federation, Jesse, there's something I've been wondering is I'm not clear on, are people expected to host their own gateway in their infrastructure, or is there a cloud kind of like offering from Apollo where you kind of plug in your services and you've got a gateway running somewhere?
Good question. You run it yourself? Period. Right now? Question mark. I mean, I think that a lot of the times running it yourself. I know GraphQL is already like a complicated. Maybe people want to figure out like GraphQL, is this right for us? And I don't know if like the story of like just we're also suggesting you maybe can run it in the cloud. Like look, I mean the gateway can run anywhere. Like theoretically it could run in the client. That gets a little bit questionable in terms of like, what are you doing? How many requests are you making?
Yeah.
And like mobile clients are still a thing, right? Like if they need to make a bunch of requests all over the place, maybe that's not right. But yeah, it's a piece of infrastructure that you deploy and is in your environment and talks to your services. So usually like the communication between the gateway and your own services is happening on an internal network, and which you control. Doesn't have to, I guess, but that is the thing we recommend.
Nice. And do you have any like recommendations or things in place in the gateway code as far as like resiliency goes, or is that like, for example, like one of the federated services starts timing out, or is being slow, or is receiving too many requests and starting to like rate limit you? Does the gateway do anything like maybe like are the links like nullable and you can return like partial responses there, or do you leave that to the user basically, or does the gateway do anything smart about that?
It is a best effort. We will do the best we can. And I think that is like nullable is like, I like nullable. I don't mind nullable. Like I do find myself in SQL databases writing the word not null a lot. Like it is my default like thing I type when I'm defining like a table. Mainly because I don't want to like I don't want to think about what happens if that piece of data is missing. However, on the other end of the wire, like I feel like it's much. It seems much more reasonable to be very flexible with that. Who knows what your client is capable of doing? They might be really well equipped to deal with that lack of data. Maybe they can just make the experience way better for their users. And it's the same thing. and communicating to the downstream services. So if one of the like our default mode of operation is like, yes, if that part of the graph just doesn't come back, okay,
Yep.
here's what we have. So like we do value completion and stuff on it when it comes back to the gateway, and that should return according to the contract. So like if you said it has to exist, then yeah, we're gonna have to throw a validation error and say sorry,
Right.
like we didn't get what we wanted.
Yeah, I think more and more as years goes on, I've been playing with GraphQL. The less I want to put anything non-null, like just everything is nullable. Even if you think it's not, it probably is. It makes things much simpler.
Yeah, it's also harder to type that exclamation mark.
That's true.
Oh, so much harder.
Yeah, it's like a shift, like ring finger or something reach. I don't know if I want to do that.
It's
too
bad
often.
for you.
I already moved my escape key down to my caps lock, and like I don't like shouting. I do like shouting. Actually, that's not true. Shout my default mode of operation might actually be a little bit loud.
Other question that I had on my mind that I really need to ask is you mentioned like query plans, caching query plans. If I'm somebody operating the gateway at my company and something starts being slow, like I've got a particular query always timing out from a particular client, is there any way for me to see like what the gateway thinks the query plan is and what kind of like instrumentation or observability is that tied to the kind of the GraphQL observability Apollo offers too, or?
Yeah. In Apollo Studio, you can see the tracing of exactly where your service boundaries are and see sort of like where a bunch of time was spent. We do send the query plans to Studio as well, so those can be like analyzed, and you can be like, this is what is happening. There is a dependency between these services, and like one of them's just particularly not as fast as it needs to be. It gives you the observability with pretty, like, I don't know, with the complexities of a graph. Like there are so many things you can do that there are concerns that are really fun to think about doing at the field level, right? And understanding exactly the way that a field is being used, or what its role in the whole query plan, or why it's being queried at all. All those things are really cool, and you can literally, because there's also like client awareness too. So you have like React app version 45 is sending all these like, they shipped a version of it for a few hours that did some funny stuff, and they fixed it already, but like that explains why my pager went off or whatever.
Yeah, it's so helpful to know that and not have to like guess.
Yeah, it's nice to be able to like look at the query plan, and we have this sort of tool that we're playing with internally right now, which is pretty cool. It's called Federation Workbench, and it lets you like sort of play with the directives that you're applying to your graph to see what the resulting query plans would be for particular operations. So you can kind of tinker with it and be like, so I did manage to pull in every single service on the entire like network with this query. How did I do that? And you can see that. You can be like, okay, well.
Nice. So you can kind of do like an equivalent of a SQL explain for Federation. Like you send in a query.
Yeah, and that's exactly where the tooling stuff like becomes pretty cool. Is you can understand those things. Now you like and hint, like basically hinting at what you want to happen. That's something that might be doable as well. So, and this plays into like sort of why we think investing in Rust is really beneficial here. We think we can basically statically generate like the possibilities and really understand those super well. Pre-compile them. Like query plans right now, we're compiling them dynamically, but we could, in theory, compile them ahead of time. Especially if you have a limited list of these, you can just say like pre-warm my gateway with every query plan it needs to do its job, and you won't have to worry about some odd thing getting in. And you can of course lock that down more. Like I don't know if your APIs, the Twitch API is not public, right? The GraphQL API?
It's public in that if you're on Twitch, you'll hit it, but it's not public in that as a developer, you can do whatever you want with it.
Okay. All right, and I know the GitHub one is public. It's wonderful, and I did some really cool stuff on it. Just actually yesterday, I was able to query. I was moving. So actually, this is probably a good thing just to say out loud. We just because we sort of see Federation and Gateway kind of becoming their own like product separate from Apollo Server. Like it's been with Apollo Server as long as it's been for the last year and a half, but like the usage has gone up like pretty dramatically to the point where it's a piece of infrastructure now that actually different types of teams want to put in front of their product teams graphs. So product teams can still pick up Apollo Server and use that, and it's or any of the other Federation enabled servers. And then like infra teams can put like the gateway in front of it. So we actually just moved Apollo Gateway from the server repository to a new Federation Apollo/Federation repository on GitHub, and it's like, well, there are a bunch of issues and PRs that need to be moved here. And like PRs obviously are the most important to me. I was like, you can actually query the GraphQL API on GitHub and find out all the PRs and which files change within those PRs and pipe it to JQ. And I was like, here's the list of every PR that I need to manually generate a patch file for and bring it over to the new home. So pretty cool. What I was getting at though is with your API at Twitch, you can use like something like Operation Safe Listing or something like that, where you only allow specific operations. You might use something like this already, like persisted queries, just regular persisted queries or something like that. And then you know exactly what your query plans are. Nothing, right? No edge cases in your query planning.
Yeah, it's an interesting technique because you could like in your client you could version ABC of this client has these queries, and you can see exactly which ones you want to support and who references what. So it helps in even knowing like not even who's using your fields, because we get that information, but the one problem we have pretty often is like who's referencing this field, and if they're still referencing it but not using it, because maybe it's a smaller client. We have many clients. You still don't want to break them. So that's something that would be super helpful in knowing that, because we don't always have access to every code base for all our clients. It's not something we have now, but it's something that I'm always kind of like keeping my finger on and seeing like, when's the right time to really pull the trigger on this and dive in.
Tony, are you saying you know who's querying the fields, but you don't know if they use them like in their code base?
So we don't version our API, and so we'll add stuff and we'll remove stuff, and we do this quicker than we would for a public API. And sometimes we run into an issue where something was added, it's referenced in a client, like maybe our web client, and but it's not used. So we don't get any usage metrics out of that because it's not, maybe it's behind the feature flag or something, and it's not getting asked for. But when we remove it, it'll break their build, and then we have to figure out like, wait, why did this happen? Like, how do I fix it? But if every time the client built and they registered, this is everything I'm looking for, we would have that data like, okay, this version still references this. We still have this many of these versions in the wild. We should hold off, or like, no, this looks good. We can go ahead and remove it with complete confidence.
Yeah, it's pretty nice to be able to look and see all the weird tools that we built against our own API and see, because we identify them with like a client name or something like that, so they show up in the stats, and you're like, that's where that field is really not importantly being used, but it was fun. Like, we didn't have select star like we would in SQL, but like we basically did it anyways because like we just tab completed all the fields in that selection set, and we're like, yes, we want all of these, but we didn't really need them. It was just fun to print out. But we can see that, and we can easily reason about that and be like, okay, that's not really being used.
Yeah. So. Yeah. That's super helpful. I've been thinking about this ever since you mentioned Rust in Wasm. I can't stop thinking about it. I haven't used Wasm and I haven't used Rust. They're both things I want to play with. One of the most interesting uses that I haven't really got a good use case for is deploying Wasm at like the CDN edge, like close to like in points of presence across the world to speed things up. And I wonder if that's like something that you see as an opportunity, or if that's still kind of like an out there use case that's kind of a fun thought experiment, but not quite ready. Like if you were to put your gateways in points of presence across the world, like would that be beneficial, or is that just kind of a crazy kooky out there use case.
I don't think it's crazy. So like I think the fact that we can compile the Wasm is really great, and it's beneficial for us right now, especially as we can offer like an incremental migration to like a more fully featured like whole Rust non-Wasm thing, but from the same Rust code base. Like we're not going to have to rewrite this code. Like really all we had to do to compile it to Wasm is define sort of what sort of like bindings are generated from the Wasm code and exposed into the JavaScript kind of shell that sits around it. And there are already multiple CDN providers that do allow you to run Wasm at the edge. Like I think Cloudflare and Fastly are the two that are doing that. Not actually sure how Fastly does it, but like Cloudflare is just V8 it's V8-ish at the edge, right? So like it supports WebAssembly.module, and you just load it in. I think that's the Wasm story there, but that's fine. Like it works quite well, and the trampolining, like in the earlier days of like of Wasm's existence and like compiling, like going across the trampoline, it definitely was a lot slower. But there's been some incredible breakthroughs. Like I'm pretty impressed even myself. The last article I read about like the trampoline was by Lynn Clark at Mozilla, and it was about sort of just how it's much faster now. And it's an incredible article, by the way. If you haven't read the article, it's fun. It's animated, and it's really like a great story. That was written years ago now, and I think that it's just continued to improve. So running Wasm at the edge is entirely possible. Even like the Apollo gateway today, I think in theory, if you wanted to set that up, it would work. Now, of course, your underlying services probably should be at the edge as well. And like sometimes, I think in general, I think the edge stuff is sometimes you still have that backhaul back to where you're maybe like most honest source of truth data is. Like, like where you're like, I don't know how far off behind that source of truth we can be. But yeah, it's absolutely possible.
At the very least, to like, if the gateway has a good query cache or something, that would be super helpful there. And then if you don't have it in cache, you might have to go back to your services or data stores that are maybe not at that point of presence, but still could be nice.
Yeah, and if we can compile, like depending on like one of the things that makes it a little bit more costly to do is the fact that they're ephemeral. So like they kind of go away and you lose anything that you have stored in memory. And we do cache the query plans in memory. We did try persisting them to like Memcache or Redis or something like that. And that's fine, but they are quite large in terms of like bytes on the wires. So like the amount of time that it takes to actually generate the query plan was usually much, like we've generated some large query plans that are like 3 megabytes, right?
Yeah.
It doesn't take that long to generate that on the actual. Well, that's like that's in a non like super optimized format, sure, but like we could probably really tweak that and get it down. But just computing it is actually pretty quick. So like if we can pre-compute those and put them into the bundle that you deploy to the edge or into the Wasm file or otherwise, then that's a pretty nice story. Although I was very, very intrigued by, for example, Cloudflare's key value store, how you can have it like kind of globally distributed by writing it there and just reading from that, and that would work. You could still warm your cache up that way. True. It's there would just be a little bit of time to read those, and most query plans are not 3 megabytes. Just that's again, people select a lot of fields with GraphQL sometimes. A lot of fields. I don't know what you've seen in the wild, but sometimes I'm just like, okay, that makes sense why you are getting all of that stuff. Like you're getting it all, and you have a complex viewport to put a lot of things on and paint a lot of cool stuff.
Yeah, that makes me think. We were talking about schema usage, and I was going to say that's the thing I love most with our infrastructure at GitHub right now is we have that field usage, that schema usage, like down to every fragment you use, fields you use, and we just like through this we discover use cases we're missing, but that nobody told us. So like I remember we see those queries sometimes with a long list of aliases to fetch, like, let's say we have a singular field to fetch a user, and people want to fetch like 1,000 users. Well, we don't expose a users field, for example. Then you will notice like query documents that are just like 1,000 aliases people want to, and yeah. So people craft like pretty huge documents sometimes that you don't expect.
It's hard to know what people are using in the wild.
Yeah.
And I do really appreciate what, I think actually we were talking about this maybe last week with, or I don't remember who it was about, but like brownouts that the GitHub does. I think it's a pretty cool idea. We recently got like a notification about like a field that was presumably like being renamed or installation repositories or something like that. Anyways, you're probably aware, but it was a webhook though, right? So like you don't really know what fields are being used on a webhook.
Yep.
Although it would be really great if you could, because like we definitely were not, but the amount of places that we had to go look to see like, they always send this on their webhook. We don't actually ever use it, but like, how do we quickly figure this out? And it took like, whatever. Like the brownouts I think probably worked, but also like ultimately we realized that nothing broke because we don't use it. So like the brownouts are a good signal, but like we didn't.
Yeah, that's like GraphQL webhooks would be so cool. Like if companies started doing that.
Yeah.
Because there's so many times.
You all thought about that yet?
There's talks. I don't know. Like, it's there's so many ways to do it. Because like, if you're doing GraphQL webhooks, is it like subscriptions with a webhook transport, or is it just like your classical webhooks with each webhook has a schema? There's like kind of a nuance. But it'd be very nice if like
you tell me
there were like providers that would just having a type, like a GraphQL type for a webhook payload, like not even as a whole schema that you can like fetch other things or anything. That would be dope. And then, or even like if you don't want to use GraphQL, if at least there was like a way to select the fields you want. That's not something you see often on webhooks for some reason, and it's just so annoying because like there's some people who receive giant payloads and then they just use it as a notifications to like go fetch something else. So you waste so many bytes on the wire. So
you are sending us so many things that we don't need, and it's not your fault. It's not your fault. It's probably partially our fault. It's sometimes too easy to sign up for them. It would be pretty cool though. It's pretty cool to think that you could, as part of like, I don't know, an SDK or something like that, you could generate types from your webhook like schema to just like provide, like instead of, I know a lot of these things right now are like largely like sometimes they're handwritten, like type definitions and things like that for things you might expect to come on a webhook or an event of some sort, non-GraphQL APIs, and doing code gen, that would be pretty cool.
That would be very cool.
I actually really like the idea of treating it as a subscription, just with a different transport. I don't know how that would work. Like, it'd be really interesting to vet these out. Like, that's like a really, I think, compelling idea, because it's same with us. Like, we use webhooks in a couple of bots that we write to like automate our GraphQL review process and whatnot. But we don't always. There's a lot of data on those webhooks, which is fantastic because you're not often left wanting more data. On the other hand, you typically have that overfetching problem where I only use maybe like 2 fields, and then
it's the same problem that everybody had with the typical like HTTP request, but it's there with webhooks as well. So
it's an interesting idea. I like what this is happening, because I know that we're talking about like doing like support like on Studio side of things, having more generic like webhook facilities that people can subscribe to understand like how their schema changes and stuff like that. Like right now we have Slack notifications where you can like every time your schema changes you get like not a push notification. Well, it depends if you have your phone on do not disturb or not. And you'll find out that like, oh, this field was removed and it was a non-breaking change because of like there was no usage on it. Like because we have all the usage stats and stuff, we can basically tell you in your pull request that your change is not actually going to break anything. Good for you. There's no usage in the last 30 days or whatever. So great. But like the webhooks that we do want more generic webhooks as well, so that's not just for Slack. So like there might be some interesting exploration to do there for sure.
Definitely. Yeah. I think the only strange thing with Webhook is that it's such a long-lived thing. Like when you subscribe to a webhook, usually, like if I take GitHub for example, I usually people will set it up like via the UI and then you put your endpoint and everything. It's like a slow configuration process and then it usually lives forever. So
Yeah, I have no idea how to turn it off.
right.
It just keeps coming.
So with a subscription is like, so you make a GraphQL subscription, and then somehow you're registered to something. It just like it seems part of another workflow. Like it's never going to be part of your app. Like the code to like subscribe for it. Usually, it's like it's more meta than the queries in your app, which is strange. But it would still work. I want to go back to the compile query thing because that blows my mind. And I think like persistent queries is the first step where it's like, okay, sweet. I'm not even sending anything over the wire. I can skip validation. So you save like a lot. But then there's still the whole overhead of running like a GraphQL engine, that dynamic thing, even though you know exactly what the query is. So like compile query sounds completely amazing because now you're basically equal with if you just define a static endpoint. It's like a static query plan. You didn't send anything over the wire for the request. But like I still ask myself, like, how do people actually do it? So you had that Rust gateway. Imagine you were compiling queries. You knew, is that like a build time thing? Can you like?
Well, I mean, in theory, yeah, absolutely. We haven't built these things,
right?
By the way. So, like, by the way, when you say in theory, your phone might think you said, "Hey Siri."
That's what I heard.
And now it actually thinks I said that. I think my other dog, by the way, her name is Lemon, so she's not responding to it, but she seems really intrigued.
We don't see her on stream. Can you show? We want to see.
Oh, okay. She's over yonder. She's
nice.
Clearly been really nice. My other dog, though, her name is actually Fedora, named after both the operating system and a hat that I thought was really cool to wear 11 years ago, and also a color in the Bear color book at Home Depot. All the stars aligned perfectly, but the other dog answers to when I say the word that triggers my phone that I'm not going to say right now, so I don't have to fight with that again. She comes running over to me every time, and it's almost like a second. I have two assistants, one digital, one furry, and it's really nice. Yeah, so like compiling them ahead of time. I mean, if you know that you can register your operations, like with Studio, like if you're especially this works really well if you have a client code base that you control. Like we're only really thinking about like compiling query plans and things like that ahead of time right now. But like there's a lot of things we can compute ahead of time, and it's fun to think. I don't know. It's fun to think about it. We'd love to talk to anyone about those sorts of things. It's exactly why we think that this investment is worth it, particularly in the tooling side of things. These are all things that you could, you can easily, like, infra teams can like reason about even after the fact. You can know that these are the artifacts that were used, even without like logging out like your query plans or something like that in real time. You can be like, well, the server definitely used this query plan. It's written right there. Yeah. And that's, I don't know, I think the possibilities are pretty cool.
Do any of you know how people do it currently? Because I know some people have tried it before. Is it like code generation or something smarter than that?
I know that people precede like their server, like APQ is what it's kind of like the automated persistent thing we do, which is much more like a handshake agreement between the client and the server, where the server is like, you sent me this short thing. I have no idea what that is. Thanks for trying. Can you try again and send me the whole story, right, and then I'll save it for later, which is nice. But I think otherwise, if you can grok all of the operations out of your code base, then nothing preventing you from putting like a manifest in there that pre-populates them. I don't know all the. There's a bunch of different ways of doing those sorts of things, and a lot of them I feel like they come down to. Sometimes it comes down to saving bytes in bundles. That's a reason why sometimes people just remove the operations entirely. I don't like. I do know that having the idea of the shape of the operation on the client side is pretty beneficial, though, in terms of like allowing the client to do really cool caching stuff.
Yeah.
Like, I don't know what Apollo Client 3's caching story would be if it had no idea what the operation looked like, because it can do some really cool stuff right now because of that. But if it just has a SHA, I don't know if
That's true.
It can probably be compiled in. It could probably be compiled in.
Yeah, that makes sense to me, like from the persisting part. The part I'm wondering how people do it, which seems really complex, is like the compiled part, where like when the query hits the server has like like somehow just runs one function to return the exact payload they're looking for. That part seems like really magic to me, and I know some people are doing that, but I don't know how. I'm really curious.
I'm not really sure either. I mean, I know there's been like on the JavaScript side of things, there's been some like just-in-time
Right.
stuff where code like instead of doing like in JavaScript, like one of the parts that you see show up on flame charts all the time is value completion from the like underlying like you get these. We need to make sure it checks out with the contract, right? You sent us back a data thing. And is it a string? And does that match the thing? And that's a pretty expensive part of at least the underlying JavaScript GraphQL JS implementation. There's a project called GraphQL-JIT, I think, that basically evals more verbose code, and V8 can optimize that out pretty quickly. I suspect there's pretty similar stories.
Oh, Zalando, that's what I remembered. Yeah. Really... Interesting.
Yeah. I think we saw them talk about this in Berlin at GraphQL in Berlin. Yeah. It's missing a couple things that make it spec compliant, I think, right now. Like it doesn't support skip and include directives, which actually I forget about these all the time. I work entirely on the server side of things, and like clients do send these a lot.
Yeah.
And do you all use skip and include frequently, or?
We do for some of our clients. The way our schema is structured, I guess this is one of my biggest pet peeves is like there's not a difference between like a user and a viewer. Like I think we discussed this with Dan Schaefer from Facebook. Like that seems like a really nice thing. Like the viewer being, I'm the user who's looking at the page, and it only has the fields that I can see. Whereas we just have one user type where that kind of mixes stuff that you can see on a different user and stuff that you can see on yourself. And so we'll skip those fields that the client knows you're not logged in. So it's not going to ask for something that it knows it won't get back. So it's just like, just skip this if we're not logged in based on the state that I'm passing you.
Yeah, we use it for very, very similar things. And I keep forgetting about it too. It's like you review code where it's like there's an if with a query and then else another query. It's like, oh shit, right. You can just like have a query and do it inside of the query instead of outside the query, which is always better. Yeah.
No, it's a really great ergonomic to have. I'm really glad it's there. But yeah, whenever I look at that as when I first saw it as a thing that it didn't support, I was like, maybe that's not used as often as I think it was. But when I investigated, it was like I checked like the operations that are hitting our graph, and I was like, never mind. Like, important feature.
Yes. All right, sorry everyone. My computer absolutely got destroyed by OBS. We were just talking with Jesse. I also got a brand new MacBook Pro 16-inch, fully spec'd out, thinking I was fine, but I'm definitely not. This is the worst. So I'm gonna buy a proper PC right after the stream. And apparently,
I'm only all the way around the world, Mark. Like all the way around the world.
That's true.
It's almost a miracle that it's just even working. Like I'm in San Francisco. Marc, you're in Quebec?
Yep, that's right. Canada, East Coast.
And Jesse, you are?
I'm in Helsinki, Finland.
Yeah. So sort of miraculous, almost magical, but falls a little bit short.
Yep, almost there.
Also, I'm on a mobile connection. I don't think that's something I should. But like that's really all we have actually. It's 5G for what it's worth.
Oh, there you go.
but like we don't have a physical internet connection. We have like 12 SIM cards just floating around our house that are all tied to mobile devices. But like this is the home of Nokia. Like so like this is a country that was built on like rich wireless roots.
Right.
Now may it rest in peace.
Yeah.
But like they still like run most of the equipment all over the place, right? So like everything is wireless here. Nobody here has home internet. Everyone has a dongle that they just have a SIM card, and like it's like at GraphQL Finland. You were at GraphQL Finland, weren't you, Mark?
Yep, I was.
When you came here,
Yeah.
they gave out SIM cards to everyone at the conference with free data and calling because like it's free here. Basically,
That was still like the nicest touch I've seen at any conference. Like getting a SIM card is so nice instead of like a mug.
Yeah. Anyways, yeah, we were talking about GraphQL. I think the last thing we talked about was GraphQL JIT.
Yeah.
So that was a long just-in-time moment.
It definitely was. And I think at this point, I think we're going to let you go. It's been like an hour and a half. But I did wanted you to plug anything you want to plug, either personally with Apollo. Do you have anything you want to shout out to?
Last time I ended a Twitch stream was a GraphQL Summit, and I started singing a Kermit the Frog song.
Yes.
I'm not going to repeat that right now. Tempting, no. But yeah, I mean, we're at look, Apollo is doing a lot of cool stuff with GraphQL. We are doing a lot of stuff with Rust now as well. We're really excited about that. We are hiring, and we would love people who are passionate about pretty much all the things you're talking about, or feel like they might be passionate about those things. That's also totally fine. So reach out to us about those things. In terms of like Federation stuff, we would love, like I said, that there's a repository now. It's like the home of Federation for Apollo things, and we would love people to give their feedback on how things are working. We love understanding how users are using, how many query plans they're making. If query plans are a problem for them, if they need more exotic query plans, they're all really great stories. We love talking about them. So I think that's where we're at.
Awesome. Yeah, Rust plus GraphQL does sound pretty fun. So I'm sure there's a lot of people who are going to be interested. So definitely do reach out to Jesse. For Tony and I, we're going to be back Tuesday to the normal schedule, and I just got confirmation. Eric Wittern from IBM's in a research group there who wrote that paper on
cost complexity.
Yes, yeah. That's right. He's going to be on. I'm very excited to talk about that nerdy stuff with him, especially since I think the GitHub API was part of that paper as a kind of as a test. So it's going to be really interesting. Tony, anything to add?
Yeah, Jesse, thanks for taking the time to meet with us. Like, I have no idea what time it is in Helsinki, but I know it's probably pretty late. So really appreciate you taking the time. And
it's the time of the year where the sun is actually starting to not be up all the time. Otherwise, I could have fooled you into thinking it was the same time where you are. It's 11:30 here, but that's okay. It is about time to turn the lights out and take this dog out. And thanks to Lennon for hanging out with us for this time.
Appreciate it.
Bye, dog. All right, thank you so much, everyone. We're gonna end here. Sorry for the technical little issues here. It's gonna be on YouTube as a magically everything's fine video. So see you next week.
All right. Thanks.